For millennia, humankind has looked up at the night sky, wondering if we are truly alone in the vast expanse of the universe. Each twinkling star represented the possibility of distant worlds, each one a mystery waiting to be solved. But for most of our history, the idea of other planets beyond our own solar system was just that, an idea, a speculation, a dream. And yet, in recent decades, science has shattered this long-held mystery. We've discovered that exoplanets, planets orbiting stars other than our Sun, are not just possible but common. In fact, the discovery of thousands of exoplanets has revealed an astonishing variety of worlds, some similar to Earth, some radically different. Among the most profound of these discoveries are the atmospheres that surround these planets. For, hidden within these thin, delicate layers of gases is a story of the planet's past, its present, and its potential future. An atmosphere is much more than just a blanket of gas. It's the life-giving shield that protects a planet from the harshness of space. It regulates temperature, holds onto water, and filters harmful radiation. In short, an atmosphere is what makes a planet livable or not. When we look to the atmospheres of exoplanets, we're looking for clues about what kind of world exists beneath the clouds, or in the case of some worlds, what may have once been there. Is the atmosphere thick with carbon dioxide, like Venus, creating an inferno of extreme heat? Or is it thin, barely clinging to the planet like Mars, leaving a barren desert landscape? Or, perhaps, is it something more familiar, like Earth's own life-sustaining mix of nitrogen and oxygen? The atmospheric composition holds the answers to many questions, from how a planet formed, to whether it could host life, to whether its conditions might change over time. And the more we study, the more we realize that these atmospheres can tell us something about the very nature of life itself. Studying an exoplanet's atmosphere might seem like an impossible task. After all, these planets are light years away, and their atmospheres are often faint and distant. Yet, thanks to the ingenuity of modern astronomy, we can observe these distant worlds in ways that would have been unimaginable just a few decades ago. One of the most groundbreaking techniques we have is called transit spectroscopy. When a planet passes in front of its star, it blocks a small fraction of the light. This event, known as a transit, is an opportunity for scientists to analyze the star's light as it passes through the planet's atmosphere. Different gases absorb light at specific wavelengths, leaving telltale signatures that can be detected by even the most powerful telescopes. With each passing transit, astronomers can decode the chemical composition of an exoplanet's atmosphere. The presence of certain elements or compounds, such as oxygen, methane, carbon dioxide, or even water vapor, can reveal much about the planet's potential to harbor life or the lack thereof. In this way, the distant atmospheres of exoplanets are brought to light, revealing their secrets in a way that feels almost like reading the pages of an alien diary written in the language of light itself. The exoplanets we've discovered are as diverse as the stars themselves. Each one seems to have its own unique atmosphere. Some are hot and toxic, others cold and lifeless. And in the vast reaches of space, a world's atmosphere can hold clues not just to its current conditions, but to its very nature and history. Take, for instance, the so-called hot Jupiters that orbit close to their parent stars. These massive gas giants have atmospheres that are exposed to extreme heat. Temperatures can soar to thousands of degrees, enough to vaporize metals. These alien worlds may seem inhospitable to life, but they provide a unique laboratory to study the behavior of gases at high temperatures. Scientists have discovered that these atmospheres can contain strange, exotic molecules, and some even have weather systems made of molten metal rain. And then there are the exoplanets with atmospheres not so different from our own. Some worlds sit in their star's habitable zone, where temperatures are just right for liquid water to exist. These planets are tantalizing, their atmospheres potentially capable of supporting life as we know it. Some of these planets, like Proxima b, orbit stars that are within a few light years of us, close enough that one day human probes might reach them. It's this diversity of exoplanet atmospheres that is so fascinating. With each new discovery, scientists get a glimpse into the infinite variety of conditions that exist in the universe. Worlds we can only dream of, each one holding a story that is waiting to be understood. Amidst all this variety, one question looms large. Could any of these worlds support life? As we study the atmospheres of exoplanets, we are on a quest for the faintest whispers of life, a signal that we are not alone in this vast universe. In the search for life, one of the key signs scientists look for is oxygen. On Earth, oxygen is produced by plants, animals, and microorganisms, making it a powerful indicator of biological activity. But oxygen alone doesn't tell the whole story. It needs to exist in balance with other gases like methane, carbon dioxide, and water vapor, in a way that suggests the presence of a stable, living ecosystem. In addition to oxygen, scientists also study other gases, like nitrous oxide or phosphine, each of which could point to biological processes at work. The detection of any one of these molecules, especially in the right combination, could suggest that a planet has conditions suitable for life, or at least that life may have once existed there. This search is still in its infancy, and the road to a definitive discovery is long, but the potential is undeniable. The idea that we might one day find evidence of life, however small or alien, on another planet is one of the most exciting possibilities in the field of science today. And now, with the launch of the James Webb Space Telescope, we are entering a new era of exoplanet exploration. Webb, positioned far beyond Earth's atmosphere, will allow us to study these distant worlds in ways never before possible. With its advanced infrared capabilities, Webb will be able to detect the faintest heat signatures from distant planets, allowing scientists to peer deeper into the atmospheres of exoplanets. Webb will help us answer questions that have lingered for centuries. Is there life on any of these planets? What are the conditions like? And what does the future hold for them? Webb's ability to study the atmospheres of planets in the habitable zone will be particularly crucial. By analyzing the chemical composition of these atmospheres, Webb will bring us closer than ever to identifying planets that might one day be home to life, or perhaps even a new home for humanity. As we look for signs of life, we're also looking for planets that could, in the future, support human habitation. Earth is unique in its ability to foster life, but with every new discovery, we are learning that our solar system is not the only one with habitable potential. In the search for habitable exoplanets, astronomers focus on the habitable zone, the region around a star where conditions are just right for liquid water to exist. But habitability goes beyond the distance from the star. It's about the atmosphere. Is it thick enough to provide warmth and pressure? Is it rich in the right gases to create a stable, life-sustaining environment? Some of the most promising candidates for habitability are exoplanets like Kepler 452b and TRAPPIST-1e, planets with similar sizes and temperatures to Earth. These planets sit within their stars' habitable zones and have atmospheres that may support liquid water, making them prime candidates for future exploration and study. As technology continues to advance, the future of exoplanet exploration is bright. With next-generation telescopes and groundbreaking new methods for detecting distant worlds, we will continue to search the skies for answers.